What's up, everybody? Welcome, Patreon growers. Thank you guys for tuning in. This is the first of its kind as far as sort of like a podcast, just a conversation. I'm Jake, MI Gas. If you guys haven't seen my face before, I know it's not shown too often in the videos. It's usually first person and whatnot, but we just crossed over 100 posts. We're just hitting the 3-year mark of Patreon being online. And so you've probably noticed a trend that I've started to recently include more people in the industry weighing in on certain things. A lot of them, there's a lot of experts and specialists out there in various fields. And, I get asked a lot of questions. People look to me and come to me for a lot of things. And there's a lot of things I don't have answers to. And part of the reason that all this has been so successful is because I'm seeking out the same answers that most of the growers that are following this are seeking. And I'm as much as a customer and a student of this as I am, on the production and teacher side. So, and I've been maintaining now for a while that one of my main goals is to get the smartest people in the room talking and having conversations that everybody's, I see a lot of these conversations happening in little corners, and I want to bring them up to the surface and expand the audience and expand the conversation and move things forward. And that's worked pretty well for me so far. So I don't know if this is going to turn into like a formal podcast situation. We're just doing Zoom today. It took a little bit to get this figured out, but we got it figured out. So yeah, I've got Michael Kutro here, former owner and founder of Green Bonnet Farms in Oklahoma, and owner founder of TriCleanAir HVAC systems. And that is that correct, Michael?
Yeah, innovative solutions, what we call it.
Yeah, yeah.
But yeah, innovative solutions. We don't just do HVAC, we do water treatment, air purification, everything really besides lighting and controls. Those are the two areas that we really don't manufacture anything for.
Okay. Good deal. So Michael and I have been talking for a while since back when he was with Green Bonnet. We're talking to somebody here who has built and sold cultivation businesses. Somewhere I hope to be someday myself. Do you want to start giving me a little background about your experience, just kind of a brief overview of your experience in the cannabis industry or business in general, and
Yeah.
what led you to here?
Yeah. I've been in the industry my whole adult life, I like to say. Started off as most people do, in whatever they call it nowadays, legacy market, I think is the technical term. Um, filling up garages, building little outhouse buildings, HPS lights, not even the double ended, just the old school, hanging them from the ceiling with no reflectors, done it all. But along that whole journey of 4 lights, 10 lights, 20 lights, 4 houses, 10 houses, the thing that I was always passionate about and successful in, more so than the growing aspect of it, um, was the building and designing and understanding how all this is working, how it's supposed to work, what can we make different, where to get all this stuff, not from, let's call it the hydro store. Back then it was, oh, you need something, go to the hydro store. It comes from other industries. And so I was trying to bridge that gap and see where our industry, it was a long time ago I'm talking about, but where we were, kind of being left away, like left out. Like what are we missing? Like what do true indoor tomato growers need? Like where do they buy shit? And so I took all that and really started trying to progress that into, the industry that we were in, which was, cannabis. And then, fast forward, legalization comes. Now the world just opens up to, access to knowledge and things that come from other industries. And I just kept riding the progression of innovating and building equipment, specifically HVAC and, water treatment, how to make this stuff better for us. Within our own facilities and then within friends' facilities and things. So that kind of led us to where we are today, which this is our, core business, which is we manufacture custom HVAC, custom water treatment for cannabis facilities. I mean, we can do it for any industry, like, critical climate industries, data centers, but cannabis is our prime focus. What I've learned is that during this whole, journey, it's hard to find businesses that truly, specifically HVAC, that can build custom solutions. Something that is not sitting in a warehouse or on a shelf. It's, and I learned that you need that specifically, especially in critical climate. So anything where temperature and humidity need to work together, where temperature and humidity need to be very, very precise. Off the shelf items aren't even really used in other industries. So, for instance, if you're building a warehouse or a home, you've got let's call it 1 tons, 2 tons, 3 tons, 5 ton units. And even really like 2 tons don't really exist. You see threes and fives. And then in commercial industry, you'll see like 7.5s, 12.5s, 15s, 20s, 30s, things like that. But in critical climate, you'll see 11.2 tons. You'll see 15.5 tons. You'll see. So what we were really trying to focus on is how do we manufacture equipment like that and tailor it to cannabis facilities. And that's what we've done. And the same thing goes with the other products that we offer, and is just tailored solutions. So they take time. It's not something that you can order and get it the next day.
Yeah.
But that is something that when you're building a big project or even a smaller project, there's a lot of planning. So uh, we don't see that that's really a downfall.
Okay.
The
So
time.
when you say things that are made to order it, get the next day, to try to connect the dots, make this full circle for myself, would it like train as a lot of the units that we're seeing out there in the field? Is that would that fall under that category?
That would fall under that. So train, maybe not the exact train, because train is kind of specific in the sense of like you can't like go on Google and type in like train and like find a unit for sale, because they're really strict in the way they distribute their product. But like let's use like the word like Goodman, right?
Is
Or
it
Carrier or Lennox.
Linux?
Like Lennox, those are a little easier to find. Train's actually one of the ones that's like more strict. But for instance, even Train, let's use Train as your example, right? Train usually takes 6+ weeks when you get into what they call a custom solution, which is you can add a reheat coil, you can have modulating, non-modulating, you can have different types of controls. Those units you're talking about right now, 30 weeks to get them. So that's more of a realistic time frame, right?
Okay.
But when I say custom off the shelf, it's like you need a 12.5 ton Daikin package unit. Daikin's a big company. You can go on Google and type in 12.5 ton commercial Daikin, and most likely probably find one in the next, within a month you can have one. That's what I mean, like more off the shelf. And then if you go
Okay.
down to like 5 ton units, which you see a lot more of, right? 5 tons, like there's a lot of, you can go on Google and find one that probably ship out tomorrow.
Yeah.
um but when it gets into critical climate, that where you're really being able to fine tune everything, our time frames, our lead times are below the bigger companies' lead times, which they are long, but they are below them,
Okay.
in the sense of things. But that just goes, it's a long process when you're really dealing with, fine tuning the results you're looking for. Um, but I think one of the key things that we should bring up is like the way that the old school, it's called legacy way, that people designed HVAC for your facility.
Hmm.
The old school method was like, okay, look, I'm gonna put, I got 20 lights in a room or 10 lights in a room. Every 1,000 watt light, I need 4,000 BTUs. So 3 lights, 1 ton, right? That's the way they used to do it. And even nowadays, a lot of guys do that. Even HVAC contractors still follow that procedure. which is managing heat load.
So that's I'm glad you brought that up, and I was hoping we'd get to that because this is all like I was fortunate to be in a situation where more times than not this kind of thing was handled by people like you or someone that owned the facility when I'm doing, build outs or consults or something like that. And I was only able to advise on it in a very basic way. And normally it was one of those things that I would hand off to a specialist before I knew that you did this. But as you know, I mentioned to you, and I think we got 11 comments. I opened up on Patreon yesterday. I wish I would have done it um, with more notice, but we still to get 11 people giving input was really great. And I said, hey, I'm going to be, talking with the HVAC expert. What do you want to know? And there's some really obvious things like reheat that most people touched on, but this exact kind of like equation. Somebody, Nick March, said, I'd like to know also, should we still be applying the 3.5 BTU to 1 watt rule with LEDs? And so is that kind of what you're talking about? It sounded like
Yeah,
that.
yeah. So when you say that the 3.5, right? That's roughly the same. But what they're looking at is heat, right? So every watt creates, in theory, 3.5 BTUs, right? That's actually like the number, right? So, but what we have, at least we have found, and a lot of other people are finding out this information is, you know, back in the day, let's use that as an example, right? Let's go back legacy days, 1,000 watt light. So that goes to my same number, about 4,000 BTUs per light. 3 1000s gives you a 1 ton AC, right? Okay. Now, back in the day, that 1 ton AC with those 3 lights, that grower was doing everything he could to get a pound. Okay. And so a pound of product, let's call it releases X amount of water back into the room. It has X amount of heat mass, the actual product, the plants, what we're talking about at this time, but all of that, right? So now that same scenario applied nowadays, right? With 1,000 watts, we're seeing 3.5 pounds, right?
Yeah.
So now the same heat number does make sense. You still need about 1 ton to every 3,000 watts of power, but you need 3 times the amount of latent heat control, which latent heat would be, the moisture removable ability to remove moisture, right? And and then that number even is, you know, made higher when you go into the night cycle. Okay. So none of that was really looked at back in the day. It was just like following the program we just discussed, right? You got 1 ton for every 1000 lights. You're pretty good, and get a dehumidifier in there too. Like that was the game back in the day. Now, the way we focus our TriCleanAir on designing out facilities is we actually don't even really look at the cooling side of things. We look at moisture removal, and moisture removal requires cooling. So the moisture removal loads are much higher than the cooling requirements. So as long as we're focusing on, excuse me, the moisture removal, then we know we're gonna achieve the cooling ability. And then there's some backtrack there where we go back and we try to fine tune that cooling side. But for instance, so if we're taking that same example, okay, a 1 ton unit, which would have 3,000 watts. Nowadays, that 3,000 watts is, let's say, about, let's call it 9 pounds. You can produce 9 pounds, give you some real numbers. So I can take the watts, but when someone tells me that they have 3,000 watts in a room, I don't say, oh, you need 1 ton of cooling. What we do is we put it in here. And what that's telling me is that most likely for every, let's call it 700 to 1,000 watts, you most likely are covering a 4x4 to a 5x5 area, which would you say is correct?
Yeah.
Okay.
Yep.
So
That's
then
correct.
we know that 4x4 to 5x5 area, you probably have anywhere between 9 and 18 plants in it, depending on the grow. And so we take all those variables, and then we know that if you have 9 to 18 plants, let's say 18 being the high number, you're probably running like a 1 gallon pot. Okay.
Right.
And then we know that 1 gallon pot is probably getting irrigated X, right? Everyone has their own irrigation strategies, but we take all that. So our software is taking all that. So then now we're getting to water. So we know with that, you're putting in X amount of water into the room. And that's how we're coming up with our numbers. So for us, 3,000 watts actually tells me that you really need 2 ton, like a 2 ton version of our systems, which has reheat in them. It tells me that you need around 200 pints per day of dehumidification for that same 3,000 watts. Now, with a 1 ton system back in the day, you're getting half of all that, and it would work great. It actually was really good when you're pumping out 1 pound. But now when we're pumping out, you know, 1 pound of light, now when we're pumping out 3 pounds of light, it's a whole different ballpark. So that 3.5 number doesn't really work anymore. You really have to look at the moisture load. And then, so we're looking at the fact that we really kind of need about 190 pints per day to come out of that room. And so we know that we can achieve that with with one of our 2 ton reheat systems. Okay.
Not just any 2-ton system necessarily is going to function the same way, though. Would you say that's accurate?
Yes, because most people are using just the standard DX 2 ton, which a DX would be like an expansion gas system, which is the standard systems that everyone is using, standards, in the sense of a freon based system, right? And so with the 2 ton basic, expansion system, when the system is running, you're achieving the numbers you need. But what happens when the system doesn't need to run anymore, because your system is running primarily based off of cooling? So it turns on when temperature gets above and it turns off when temperature gets below. It's not working off of humidity. And then even if it was, right, you would overcool upon dehumidification. And that would be a big problem. So, reheat is a big talk. Nowadays, everyone's talking about reheat and
Mm-hmm.
how it works and whatnot. There's basically three. You either have electric reheat, you either have a hot gas reheat, or you have a hydronic reheat. And when I use the word the electric reheat, that could also be a gas, like natural gas burner reheat. So electric and natural gas could be in the same category. And then hot gas reheat, and then hydronic. So if we go into that specifically, the really easy method that you see a lot of people deploying nowadays is they're putting in electric heat strips, and then they're using, whether it's a relay based system or a controller based system, to reheat the air that's coming back into the room, basically forcing that AC to work all night. So when the night cycle comes on, or even the day cycle, that's the thing. Even when the day cycle, some rooms, you're in Michigan, right? In the winter, it's nice and cold. That AC doesn't have to work as much because the outside temperature is not affecting the room as much. But when that AC would, in theory, turn off, you would have a spike, right? Huge spike. So what
In
the
humidity.
electric heat, yeah, in humidity, and the electric reheat, what that would allow is it would turn on a reheat coil, and now you can keep the AC on, but you can keep the room not getting colder and colder and colder. The drawback to electric reheat and even a gas furnace reheat, the drawback is you don't have ability to modulate, and you either have to, sometimes you'll overcool, sometimes you're undercool. So the system will kind of bounce back and forth. Now you can fine tune it. Electric's a lot harder to fine tune. With gas, you can fine tune it a lot more. But what you're really looking for with reheat is having your supply and your return temperature to be almost dead zero. Obviously that's very hard to achieve. But what you're trying to do is, let's call it, within a 5 degree plus or negative, or a 10 degree plus or negative. An example of that would be, if you want to set your room so it's 80 during the day and let's say 70 at night, and you want to have your return air coming in, it's going to be coming in at 80 during the day. You want to be able to supply that air back at, you know, roughly 75 degrees coming back
Into the
um,
room.
into the room if you're in a reheat cycle. Okay. If you're in a reheat, or even a little higher, right, than 80, but you want to be around there coming back into the room. And when I use the word return and supply, return means the air going to the unit, and supply means the air coming out of the unit.
Okay.
So with that being said, electric reheat can afford you some of the luxuries of reheat, which allows, basically, it'll turn your standard air conditioner that you already have in your room, it'll turn that into a dehumidifier at certain times, but not that as efficient and not as precise as some of these other options that we'll get into. It does use a lot of power. A good rule of thumb that people should understand, that I think a lot of people don't, but if you have 20,000 watts of lights in a room, and so let's say that 20,000 watts uses 100 amps, right?
Mm-hmm.
At 240 volt. Am I right there? It would be
I'd have to
5 amps per light times 20. Yeah, 100 amps. Okay. So if you have 100 amps worth of power going to lighting, you need to expect to have 100 amps going to environment. And that is something that most people don't really quantify. Yeah. That is the way. I mean, all this information, when I say like that's the best way, I'm saying like this is, when cost is real, upfront cost is not an option. Um, this is when you're building high-end luxury, let's call it, commercial facilities.
Yeah,
You,
this may
you
not apply to the guy with 10 lights in his basement.
you don't have to think of it that intensely, because you're probably doing it on a budget, and you're probably like, you're limited to what you have. But like if someone's building ground up where they have the options to, you know, get the power supply they need, or they know this is the power supply that the city's going to allow us, you need to really think that for every 100 amps, you need another 100 for HVAC. A lot of people don't do that, and they run into a lot of problems, even on a small scale. If you can allocate that on a small scale, it'll allow you to grow into other options. Where if you don't do that, you're going to be limited a lot when you get into certain system options in the future, right? And obviously, everyone wants to be able to grow, so that's just a good number, good rule of thumb. So back to the electric reheat, right? So electric reheat, and then gas. Some systems, like package systems, rooftop package units or outdoor package units, they'll have as long as they have a gas furnace, their gas heating furnace is after their cooling system, you can basically use that heat to reheat the air. And there's some tuning and things that we can, do with to get it to be more fine tuned, because we can really dial the heat load coming back into the room.
Okay.
Um,
Let me ask you a question real quick in regards to that. You're talking about, is there just certain units that have the gas after you said, what was it?
so for instance, so like I know like Carrier weather makers, there's like a common unit that you see, package unit. You need to have your gas furnace needs to be after. When I say after, I mean you have your return and then you have your supply. Return needs to hit your cooling coil first, and then it needs to heat your heat source, whether that's electric or gas heat, and then it needs to become your supply.
Okay.
There's a
That
couple companies that build it where the heating furnace is before the cooling, and that doesn't work for reheat.
Okay, let me ask you this, because I know this is going to be helpful for people. I know there's going to be some growers that have an understanding of this beyond mine, and they're probably right there with you. And I know there's a lot of people are on the other side, on my side, that have a very basic understanding of this stuff. And I believe that a lot of people's exposure and understanding of this topic has come, and I don't know how, what your, as someone who is a HVAC expert in my book, what your perception of how this has all played out. I'm sure it's not black and white, but a lot of people's exposure and understanding of this topic has come from Steve Landry, Cannabis Mechanical. And you mentioned that there's 3 different categories. There's electric, gas, and there's another one that was a bigger word. What is, do you know what they're putting out there? Is it electrical or is it gas? Is it both? I mean, I know there's a lot of retrofitting going on.
Yeah, so I'll tell you. So Cannabis Mechanical, he claims he invented reheat, right? Which obviously he didn't. Reheat's been around since 50 something. It was actually around from like the beginning of HVAC, conditioning of air, right? It's been around for a very, very long time. He was one of the first people, I will say, to like get on social media and get in front of people and say like there's a better way to do this for the masses, right?
Mm.
Commercial cannabis facilities that have been hiring engineers and following what they say have been using reheat for a long time. I've seen reheat in a facility like I don't know. I don't have the exact date, but anyone who wants to look it up, like when Las Vegas became medical, which is a long time ago, like I was seeing reheat in facilities back then, even in Colorado days. So this is way before I think the 2000 and like 18 or something that Cannabis Mechanical claims he invented reheat. But I will say he did bring it to the masses in the
Yeah.
sense of like social media. He has a kit that like, you know, the Johnny Joe that has a garage can kind of hook it up. But he focused on, at least publicly, he focused on electric reheat, right? Which is
Okay.
basically buying an electric strip, sticking it in your unit, and then forcing it to come on and off based upon your cooling versus dehumidification call. That's what he's done.
Okay.
He's now experimenting in other things and talking about other things.
How do you rate that solution for the small guy?
When you say small guy, I mean like a guy
10,
who has
20
a
lighter
5
at
ton
home.
and 10.
That's
What?
10, 20 lighter at home.
Okay, let's call that the small guy. You've got two options, right? You buy DHUs, which you already have. Look, most of these people already have the DHU. Or you put reheat in and you buy DHUs because you're going to need the DHUs too. Because the electric reheat, you can't modulate. It's very cut and dry, on or off. And you can run into a lot of problems with that. Okay, that's the bottom line. So it's a great option. It's really inexpensive to hook up. Now, power is a factor, right? It costs money to run those heat strips. So it's a great simple option, and the cost to add it into a HVAC system is so nominal. I would not frown upon anybody choosing to add it. They need to do their own research on the cost of usage compared to what they currently use or what they are potentially going to use. Is what I would say, because that is something that I don't think many people are doing. But you need to figure it out. You know, it might cost you $1,000 in a couple hours to hook it up yourself, right?
Mhm.
So that's not a big deal. Where even the smallest DHU is going to cost you way more than that. So I think it's a good option for someone to try, and then they need to make their own judgments based off of power consumption and results that they get.
Yeah.
Now, when we get into like the next step, right? The next step would be like hot gas reheat, let's call it, which requires a true professional, and not just anyone. Like you can go to HVAC school, but you're not taught how to really do hot gas reheat. It's a complex process. Even I myself, like I understand how it works. You know, I can have our engineers draw it all up, but like I'm not the guy to say, oh yeah, I can do that, right? I can do it, in our factory, but like on a job site like that. There's a couple like in the cannabis space, there's only a couple guys that I would trust hiring to do hot gas reheat on existing, like let's call it train units, right? Swoozy is one of the guys that's out there. Groku in Canada is another guy that I would trust. There's a couple of them out there. Those are just two, right? They know what they're doing with the hot gas reheat, retrofitting it, specifically retrofitting it. They know how to do it, and they know how to do it well, and it requires that. Anyone who's telling you their local HVAC guy is going to do it, you're going to have problems. It's very complex. It takes a lot of math, science, and knowledge to do. So there's a bunch of big companies that do it. Addison is one of them. Addison makes very, very expensive high-end HVAC units. They do it. They all do it, right? I'll tell you where you find the big problem. There's a lot of components. This isn't in retrofit. These are in already pre-built solutions. There's lots of problems. I can give you one example. A very predominant guy. I'll talk about his name because he posts about it all the time. But like Dave from Preferred Gardens, he has like a $600,000 HVAC system that was designed by engineers, installed by Addison. It's an Addison units installed by professionals. He did everything the right way. Those units are failing left and right. They're hot gas reheat. They fail all the time. I mean, he's constantly, obviously they're, for a while they're under warranty, but still failures create problems. Expenses. So hot gas reheat for the small grower, it's a no-no. No-no.
Okay.
The 1020 lighters, it's a no-no. Don't even waste your time with it. Either get dehumidifiers or do electric or a gas furnace reheat. Those are the things we've discussed. Hot gas in a big operation, big large scale facility, it's all being designed very, very well by engineers. It's being installed by really high, high end professionals. It's an option, right?
So did you make the distinction there that hot gas and gas furnace are two different things?
Yes, 100%. So gas furnace is just be like, you guys live in a cold environment, so you have, you either have an AC or you turn heat on, right, for your houses, and heat would be, a gas furnace burning, propane or natural gas, and then an air blower blowing air across that to create heat in your building. That would be a gas furnace. Hot gas reheat is taking the heat that would be going outside and instead bringing that heat inside across a coil inside to reheat the air. So a dehumidifier, a Quest, an Andon, even our dehumidifiers that we make, the TriCleanAir, Craft Farmer, Collab, Dehu, is basically a hot gas reheat dehumidifier. And
Hmm.
instead of having a condenser outside and an evaporator inside, all of these brands that I just listed, what they do is they have an evaporator that the air passes and cools, and then moisture is removed. And then they, instead of that heat that needs to go outside, it, instead of being rejected to an outside unit, it comes back and it gets reheated by the second coil. That's hot gas reheat. Now, with a dehumidifier, the major brands and the major ones that you know of, they don't have an option to reject the heat outside. So the heat's always being rejected inside. So dependent upon the load, depends on how much heat gets rejected inside. So there's a negatives to dehumidifiers. That's why they're not the greatest choice.
Because they're pushing
Um,
a bunch of heat in your grow room that you don't want. Is that what you're
yeah,
saying?
you don't have an option to do anything with when a dehumidifier comes on. It's basically creating a you're paying to have zero cooling and only dehumidification. And most likely heating is included in there. So you're heating your room, you're paying to heat your room and remove moisture. Where with a properly installed hot gas reheat or with a properly installed hydronic system, you're paying to dehumidify or cool your room, and that the additional heat is not involved anymore. So you're not combating it. You're not paying for something you don't need.
Gotcha.
So with that, let's branch into the hydronic systems, which that is what we now focus primarily on. Like we still can produce DX systems. We can do hot gas reheat systems. We can build you anything you want. That's the truth. But if someone's coming to us for a project, new builds, we focus on full hydronic systems. So to explain what that is um, we are cooling your room with water, and we're heating your room with water. Instead of using a Freon based system that is moving Freon through copper pipes like everyone used to, we're using water as our carrier agent instead of Freon. And the benefits to this, especially in large scale, the benefits is efficiency. It's much cheaper to move water than it is to move Freon, and specifically in long distances. And with the way we build our systems, we're able to capture, upwards of 90% of the heat that should be rejected outside. We're able to capture that and reuse it to reheat the systems inside, which gives us um, full modular ability of return and supply temperatures. And this is what gets into extreme efficiency, very, very tight dead bands, and huge cost reductions in large scale facilities. Small scale facilities, there is cost reductions, but it's not as great as the large facilities. Multiple rooms, this is what really makes the hydronic system shine. When you have 10 flower rooms, 2 veg rooms, a mom room, a clone room, 3 dry rooms, and we get it all in one big system, the efficiency is, astronomical for a big facility. We've seen, depending on cost, up to $1,000 a ton in savings in energy bills. $1,000 a ton annually for using a true hydronic reheat system in a cultivation facility, a large scale facility that has multiple rooms, multiple dry rooms, multiple veg rooms, multiple flower rooms.
And then you're talking about not only do you have the energy and electrical cost savings, but also you have tighter dead bands. You have
the ability to run. The key word is ability to run, right? Some people don't choose to do that, right? And people always ask, well, why wouldn't someone do that if they could? People have their ways. They like their certain things. When you start pushing stuff, right, like to be so perfect, it takes a lot of effort, right? A lot of tuning. Anyone who says it's a set and forget, not exactly. There's tuning involved and takes time. Where the difference between having a 3-degree dead band and a 1-degree dead band, I don't think there's any value add in that.
okay.
That's my
That's
opinion.
good to know. That's good.
Some
That's
people,
not just coming from an HVAC guy. That's a guy that's run facilities and managed thousands of plants, right? I mean, people should understand that you're not just,
yeah, I've never seen the difference there. I'll tell you, being able to run your grow room at, let's call it, I'm a hot guy. I like hot rooms. That's my opinion. So I like to run my room at like 84, 85, right? A lot of people don't like that. So that's another story to discuss. But
yeah, but I know some absolute, you know, some very good growers that run it that way.
as long as you can give it all the other things, heat's not that type of heat's not the end of the world. So, but let's just use an example of like 82 degrees, right? So if you can run your room at 82 during the day and 78 at night and not have a humidity problem, the advantages there are proven in years and years of scientific research in all types of crops. When I was explaining, like something I focused on was cannabis is just another plant, it's another crop, right? So let's get all this data from these other industries and try to apply them to what we're doing, which a guy named Bruce Busby, he's super smart with this stuff, probably like one of the foremost, and he talks a lot about this. It's like, we've had this huge ideal of like, hey, if you run your room at 80 during the day, you need to run it at 70 at night, right? Common thing.
Very common.
Okay. And the reason behind that goes back to legacy days because we need to get the humidity down at night. So running it at 70 at night, what does it do? Force the AC on all night. Not all night, but for longer periods of time. Therefore, lower humidity. With a proper hydronic system or a proper hot gas reheat system, with any type of properly designed system, I'll use hydronic as what we can run that night temp at whatever you want it to be, and it's going to be whatever humidity you want it to be. So what I was getting at is whether you have a 3-degree or a 1-degree dead band, I don't think makes a big difference, but the ability to run at whatever temperature you would like at night and whatever temperature you would like at day with the same humidity settings, that makes a big difference. That's what starts changing the way your facility works. Deadband, not that big of a deal, but having the ability to do what you want when you want, it gives a experimental playground. If you step into a new job and you're in a facility and you have to run that room at 60, 70 at night to get the humidity down, well, you're stuck. You're never going to get to try anything new.
Yep.
which maybe new isn't better, but maybe it is. You never get to learn that. Having the properly designed systems, you get to try these things. You get to experiment. You get to, all these people are doing this, let's call it strain hunting, right? Pheno hunting, I think they call it, right? Everyone's doing this. Temperature and humidity is a huge play. I come from a primarily green, like, commercial greenhouse, facilities. That's what I like, big greenhouses, temperature controlled, full environmentals. But learning how to grow in a greenhouse is a whole nother world. And it has a lot to do with pheno hunting and selection. So, doing that in an indoor space when you have full control, you can really, you know, pardon my language, but fuck with these plants, right? You can
Yeah.
really push them. You can run them and you can do things in these, facilities that, you couldn't do before. So with hydronic HVAC, like, let me explain that so everyone understands, right? So we're using a chiller, an air cooled, or we can do a liquid cooled, but a large chiller to cool the media that we call water, right? Sometimes it has glycol because we need to be able to make it so it doesn't freeze in the winter. Certain environments require it, but we're going to call it water. So we're cooling water, and water is then running into every single room, which is much safer than Freon. It's another aspect that we should talk about, right? We're pumping water through lines. Those water is going into an air handler that has a coil, and we're able to use that to cool the room. And then in that same air handler, we have a hot coil. That hot coil, we are pumping water through. That water is heated. What we're able to do with our systems is we're constantly cooling the facility, but at the same time, we're creating heat that should be discharged outside through our chillers outside. We're able to take that heat and use it to heat up the hot side of the system so that heat's not being wasted into the atmosphere. If we need it to be wasted into the atmosphere, it can be. But
But you don't
if
have to
we
spend money to create it if you need it.
we're not, yeah, the heat's already being created. So
It's
we're
already
capturing
about
that heat for free, right? 100% free heat. Um, and then we're pumping that heat back through the system into the building. And then, basically that building has a big racetrack of cold water circulating. It has a big racetrack of hot water circulating, right? And then whenever a room or an air handler is giving a call for cooling or dehumidification, there's valves that allow more cold water or more hot water in. And those valves are modulating. So those valves, we can open it just a little, we can open it a lot. Same with the heat, open it a little, open a lot. So we're really able to make that perfect differential temperature across the air handler. And we can make it as advanced as you want it, which obviously costs more money up front, and we can make it as relaxed as you want it. We can open the valve or close the valve, but modulating is the key. We can open that valve so much. What this allows the general, grower, because at the end of the day, the guy that's operating the facility, he probably doesn't need to know all this, right? He would like to learn it once, but when he sets a temperature in the room of 80 and 60, what our system is going to be able to do is it's going to be looking at the temperature in the room, and it's going to correspond the amount of cooling and heating to give him the perfect temperature in the room. And it's going to do the same thing when it comes to humidity. When humidity starts to increase, we're going to and cooling is satisfied, we're going to start to increase we're going to bring the cooling factor up, but we're also going to bring the heating up by allowing more cooling water and more heating water. And what that's going to do is keep the room at 80, but allow us to dehumidify. This is why hydronic is the best, is it allows the most versatility. This allows you to do whatever you want in the room. And at the end of the day, that is a very I think a big selling point, specifically for brands and people who are really trying to like step out into the market with cool new stuff, pheno hunting, all of this. You can do it with these systems and get the results you want, and at least experiment to get the results you want.
Yeah, absolutely. If you can control your humidity perfectly, you can control your destiny. And so I would tend to agree. On that note, this is Awesome, dude. This is fascinating information that, this is exciting to learn about. Let me give you a scenario here really quick before we move on to the next subject while we're on the topic. So